Question number. So the question is two wires A and B of the same dimensions are under loads 4 kg and 5.5 kg respectively. Two wires. So let us consider here two wires. Question number 5. Level 2 exercise 1. Level 2 exercise 1. So two wires, wire A and B, let us say are 1 and 2. And first one and be of same dimensions. Same dimensions means you can understand that length is same. Okay, L1 is equal to L, and it is having L2 is equal to L. And the same dimensions means maybe area. Area A1 is equal to A, A2 is equal to A. So two wires A and B of same dimensions means length and area are under loads of 4 kg and 5.5 kg. So here a load F1 is equal to 4 kg is applied on this. A load F2 is equal to 5.5 kg is applied. Okay, respectively. The ratio of Young's moduli of materials, ratio of Young's moduli Y1 by Y2 of materials of the wires for the same elongation is also mentioned that for this force, both even though forces are different, but elongation produced in the first one is equal to elongation produced in the second one. So then what is the ratio of these two is the question. So you have to use this as a condition. Of course, they're all equal, but you can use this as a condition, and we know that elongation delta L is equal to what? F L by AY. So delta L1 equal to delta L2. That means I can say as delta L1 is equal to delta L2 means F1 L1 by A1 Y1 is equal to F2 L2 by A2 Y2. Right? So from this you can say F1 equal to F2? No, not equal. L1 equal to L2? Yes, they cancel. A1 equal to A2? They cancel. Y1 equal to Y2? No, they're asked to find. Okay, ratio of Y1 and Y2. So we take Y1 here, then it becomes Y1 and Y2. F2 bring it here, then we'll get Y1 by Y2 is equal to F1 by F2. F1 is how much? 4. F2 is how much? 5.5. So you can also write it as into 10 into 10. If you multiply, you get what? 40 by 5.5. So you'll get how much? For 11, 5, 8, 8 by 11. 8 by 11. They have given the fraction or decimals? 8 by 11 is there. So 8 is to 11. So that is the ratio of Y1 and Y2. So option 4. 5 correct only. That's sixth one. Next. Moving to exercise 1. Right. So what is given here in the sixth one? A load of 1 kg weight is attached to one end of a steel wire of cross-sectional area 3 mm square and Young's modulus 10 power 11 Newton per meter square. The other end is suspended vertically from a hook on a wall. Then the load is pulled horizontally and released. When the load passes through its lowest position, the fractional change in length is. Load is a load of 1 kg weight is attached to one end of a steel wire. Steel wire is a steel wire. Steel wire of cross-sectional area is and model is this. The other end is suspended vertically from the hook. The load is attached to one end. Other end is suspended vertically from a hook. See, this is a hook. Okay, this is suspended here. The other end is attached to. This is attached to a load. Load M is equal to much 1 kg. So M is equal to 1 kg is weight is attached to one end of a steel wire of cross-sectional area. A is equal to much 3 mm square is equal to 3 into 10 to the power minus 3 meter whole square means 10 power minus 6 meters. square, and Young's modulus y is equal to 10 to the power 11 Newton per meter square. The other end is suspended vertically from the hook on a wall. This, on a wall. So let us say this is on a wall. Or you can say this is a wall. To this there is a hook like this. Like this it is attached. This way also you can understand. Or this is a wall or floor. You can say there is hook which is attached like this also. Fine. The other end is suspended vertically from the hook on a wall. Then the load, then the load is pulled horizontally and released. The load is pulled horizontally and released, like pulled horizontally and released. So you can consider this is a bob like this, or either way you can consider this is pulled aside horizontally and released. Okay, fine. It is when the load is passing through the lowest position, the fractional change in length is. When it is passing through, when it is released here, it undergoes oscillatory motion, right? At the lowest position, what is the fractional change in length? Delta L by L. What is the fractional change in length at the lowest position? Okay, but take G is equal to 10 meter per second square. So you have to consider this as mm, what is asked to find? The fractional change in length means elongation. Hmm? Elongation is L, right? But what you have to understand here is when this wire is under like to and fro motion, you have to consider it is a part of vertical circular motion. If you pull this aside and you release, this otherwise it's something like if you consider that a thread is one end of the thread is in your hand and the other end is attached to a bob, and if you are pulling aside, just you are pulling this aside like to keep this in vertical circular motion, kind of, right? Or if this is a actually this is a hook. There is a hook to the wall. So if you pull aside and if you release, if you pull tightly, you may make this into a vertical circular motion, like in this vertical plane. So it is supposed to be a part of vertical circular motion. A part of vertical circular motion. To understand this, we are keeping like this. So what you can understand here is at the lowest position, mg will act downwards, and tension T acts in upward direction. So net force provides centripetal force. The net force is what? Actually T minus mg. So T minus mg will be T minus mg provides centripetal force mv square by r. If it this length will be taken as radius of the circular motion r, or mv square by l. You can take it as mv square by l. So here tension will become T is equal to minus mg. If it comes here, becomes plus mg plus mv square by l is the tension. This tension is nothing but the force which is producing elongation in this. So if you original length, if you take it as L, then a fractional change in this you can find out by taking this into consideration. And you also have to understand that you also have to. So this is the tension at the lowest position, mg plus mv square by L, or mv square by L plus mg. But at the highest position will be different. Mg will act downwards. What do you call it? Tension also will act downwards. So net force will be what do you call mg. Here mg plus t plus mg will give you this. So hence t is equal to mv square by r minus mg will be right here plus mg. The tension. So at the lowest position, this is the tension, and that force is supported by producing elongation. Means what you have to understand here is. Uh, you also have to understand that um, right, you have to keep in mind this. Let us say this is equation 1. So now Young's modulus. In terms of Young's modulus, as Young's modulus and all, in terms of this, you have to represent. We know y is equal to f L by A into delta L. Well, delta L is the elongation produced. Delta L is the elongation produced, right? But F is nothing but tension here. You can also write it as tension T into L by A into delta L. You're asked to find the change in what is the fractional change. Delta L by L is what? So from this delta L by L is equal to this you send here, delta L by L you keep it here, then T by F A into Y. So T is this. A you can write it as area is given, right? So and y is also given, so you can find out the tension by using this, and you can substitute and you can find out. So but here you can understand that tension is nothing but mm, here in terms of mg, this is velocity square, right? um, can you just how can you find out by using this, what values v is given? Velocity of here it will be For the circular vertical circular motion to be completed, it will be root 5 gr. But here anything else is given based on this. mv square by L can be taken as length is given. What is the length? Area is given, weight is given, Young's modulus is given, G is given. You attach it to one end of steel wire of cross-sectional area. Young's modulus is the other end is suspended vertically on from the hook of a wall. Uh, so you have to just for this, what you have to understand is M is given, G is okay. Um, V square by R is nothing but acceleration. Hmm? Can also express here M square by R is nothing but m v square by r, centripetal force, can also be taken as mm, m into, you have to take it as v mgr as mm, by using the conservation energy, you can say um, whatever, if you are pulling aside and you are releasing whatever the energy here, total energy is nothing but potential energy. So when you once you release here, the total energy is nothing but kinetic energy that will be converted into kinetic energy. So you can also say half mv square is equal to mgh, right? So you can also say that mgh as L, what you call in terms of the height. So if you take it as mg, actually for vertical, just if you pull aside and if you release, so if you take it as mgl, then mv square can be taken as 2 mgl. Of mv square is equal to mgl, and hence mgh actually. But if you take it as mgl, mv square place you can put it as mgl. So then you will get mgl by l. So ll gets cancelled. So 2 mgl plus mgl will become 3 mgl, right? T is equal to 3 mgl. So if you bring this here in the place of tension and the substitute uh, T, delta L by L you want, right? Yeah. The other terms, so delta L by L, fractional change in length. Delta L by L is equal to delta L by L is equal to T by A into Y. So T can be taken as 3 mg L, 3 mg actually for smaller angle. It should be the length of the arc actually I can take. It is equal to, further you can take it as this is L cos theta, and it should be L minus L sin theta, or arc length. Yeah, so height if you consider, that is will be nothing but L cos theta, L sin theta. So L minus L cos theta. That way you can take it. But here those parameters are not mentioned. So in terms of this only approximate values only we have to take it. So if you consider this one as mg, let me just mgl as 3 mgl. 3, 1 second. This is mg. Wait. mv square is mv square is mgl, right? So 2 mgl, and 2 mgl, ll gets cancelled. No l will be there. Here, if you say this is equation 1, mg t is equal to mg plus mv square is 2 mgl by l. ll gets cancelled. You get 3 mg. 3 mg. For this L, you are not supposed to, you don't understand that. In this particular case, you don't need to use this one. Okay, so 3 mg is T. So 3 mg into 3 mg, yeah, by area. E into Y. So substitute this value is 3 into M is 1 into G is 10 by A is 3 into 10 to the power minus 6 into Y is 10 to the power 11 plus 11. 3 3 cancel, 10 power minus 6 plus 11 is plus 5. If it comes here, it minus 5. Yeah, this is one more 10 is there. So 10 power minus 4. So delta L by L 1 10 power minus 4. So we'll get fractional change delta L by L is equal to 10 to the power minus 4. Right? So only this you have to understand here is yes, vertical circular motion concept you have to bring. According to this, tension at this point is upward direction, mg is downward direction. So net force is mv square by r. By taking this and by conservation of energy, this you have to say. Actually, this is equation 2. You can say from conservation of energy. From, you can keep this aside. From conservation of energy. From law of conservation of energy, we can take this one. So if you take this, then m square will be 2 mg L. Here L gets come, we will get 3 mg. So T is equal to 3 mg. This if you substitute it here, again by taking this as equation number some realistic, this is 3. Substituting, then you can come out this. 17. Right. So level 1, exercise 2, question number 17. So the question is, two wires of same material have masses in the ratio. Two wires of same material means we have to say this is 1, this is 2. Same material means Young's modulus is same. Y1 is equal to Y2. I have masses in the ratio 3 is to 4. So M1 is to M2 is equal to 3 is to 4. And M1 by M2 is 3 is to 4. The ratio of their extensions under the same load, ratio of their extensions, delta L1 is to delta L2. Ratio of their extensions under same load means F1 is equal to F2. F1 is equal to F2 under same load. If their lengths are in the ratio, L1 is to L2 is equal to how much? Lengths are in the ratio 9 is to 10. What is the ratio of their extensions under the same law? If the lengths are in the ratio is what? Ratio of extensions is equal to what is the question? If loads are also same, means forces are also same. So what you have to use is same, the equation of what you call Young's modulus. So Young's modulus, we know that y is equal to f L by a into delta L. So here we are asked to find ratio of extensions. So let us take a delta L expression. Delta L is equal to what? F L by a into y. So ratio of extensions. So that is, let us take one at the constant parameters. Y is same. So this is constant. And anything else is same. Y is same. Mass ratios are given and length ratios are given. Areas, area. Did they mention anything about area? Wires of same material have masses in the ratio. The ratio of their extensions under the same load. Oh, load is same. Load is same means F is also same. Y is same, F is same. Um, Length ratios is here given under same load, and if their lengths are in this ratio is. Areas are not given means mm, mhm. Wires of same material have same masses and masses in this ratio, lengths in this ratio. So radii or diameter is given, then you can of course you can consider this. Masses are given, right? Oh, masses are in the same ratio. The ratio okay, under the same load. Load is same, but masses are different. Huh? How come that? So there are two wires. M1, so this gives F1 is equal to M1G. This is M2G. F2 is equal to M2G. G will be constant. For the loads to be constant, M1 and M2 should be equal. Same load is acting, but masses are in this ratio, different ratio. What does that mean? Let us check this once now. Volume should remain constant in terms of this other way extension under constant volume condition. If you consider volume constant case as volume is equal to area into length of a wire. Hmm? Here here mm, yeah, let us say in this expression y is equal to f l by a into delta l. Okay, here let us multiply in terms of mass you want, right? Load is same, so let us consider this is m into g, huh? And then area is not given, so you should keep area. I have to replace this with volume, so let us write multiply both l denominator with l by l. We have to replace that with some other constant parameter, means volume constant parameter. So we have to write it as f, that you have to just what do you call it? You have to understand that under constant volume length is given, right? So volume will be constant. If you are applying a load, if it undergoes extension, means you have to understand that volume will be constant. So f l square by a l is volume into delta l. Hmm? Volume into delta l. Okay, so delta l ratio you want. So what you can understand here is for a constant volume, you can also write this as both are made of same material. Same material means density also will be same. So here you can write F is mass is equal to density. F is mg, you can write mg into L square by V into delta L. This further you can write it as mass equal to density into volume. What? Density into volume into G into L square by volume into delta L. Volume gets cancelled. That also gets cancelled. Got it? Now is equal to density into G into L square by delta L. Got it? So from this you can write delta L. Masses are given, right? So no need to write them density when you are taking this way. You have to keep in mass only, in terms of mass only, mg only. No need of this. Right. Right. See, no need to express this. You have to express here as m in terms of m only. As volume is constant, I can write delta L is equal to mgl square by v into delta v into y in smallness. Smallness is constant, g is constant, volume is constant. You can write it as it is proportional to m into L square. Delta L is proportional to m into L square. From this, we can express delta L1 by delta L2 is equal to what we'll get m1 L1 square by m2 L2 square, or m1 by m2 into L1 by L2 whole square, right? Is equal to m1 m2 ratio is given. What is that? 3 by 4. 3 by 4 into L1 by L2 is 9 by 10. 9 by 10 square means 81 by 100 is delta L1 by delta L1 by delta L2. So on simplifying, what will get? Uh, can you simplify this further? Hmm? 2 with 2 or 3, 4, 5. Can you simplify with any of the parameters? Is this 9 is to 10, right? 9 square is 81. Then square is 100. L1 by L2 only. Um, L square. What is this? Extension M extension L square. You have multiplied this L with L by L. L square is value E proportional to L square. This only, right? L square by Y into V. Hmm. Is the density. This there is a small correction you have to do here. F L square by A into L is volume into delta L. So it is equal to mg L square by V into delta L. Delta L is equal to mg L square by V into Y. Hmm? So it is nothing is mentioned about volume. Can we take any other parameters in terms of other parameter? Or you have to consider volume should be constant for the wires. Otherwise L square by M. Volume density is equal to mass by volume. Volume is equal to mass by density. No squares, right? Just you have to just need to check in this one. Hmm? Actually, as volume is proportional to mass. We'll get in a different way. G is there. Or G is a constant. Let's check this once. Question number 17, right? Yes, okay. Yeah. A cable breaks if stretched by more than 2 mm if it is cut into two equal parts. By how much either part can be stretched without breaking? Without breaking. By how much either part can be stretched without breaking? So breaking stress, breaking strain relation is. A cable can break if it is stretched by more than 2 mm. Elongation should be more than 2 mm. It is cut into two equal parts. And by how much either part can be stretched? You have to compare this with elongation part, spring constant or elongation relation. Okay. Hmm. It's actually you have to consider a string and another. If you compare with spring, you have to understand that spring constant. If you compare this with the spring, spring constant can be taken as here spring force F is equal to kx. Here F is equal to here F will be equal to by A delta L, or you can take it as the extension X by F by T or force by sorry by L, because Y is equal to F uh, F L by Y A into delta L. F L by A into delta L. So F is equal to Y A delta L. Y A delta L is nothing but X by L by L. This will be taken as force constant. Force constant will changes accordingly. So here you can take this as force constant K is equal to Y A by L. When a wire is cut, the force constant will changes. if it cut into equal parts, becomes stiff, right? More stiff. So force constant will increases, become two times. So n parts, n times. So like that you have to consider. In terms of this, what is mentioned here, the elongation. See here, that elongation, okay, this is proportional, right? You can take here two equal parts means two times it becomes two times. So elongation is equal to f by 2k, f by 2k or f by 2 by a by l. That you have to consider here. Y will be same, a will be same, length becomes half. So length becomes L by 2 means it becomes 2k. So it becomes two times. We'll see this 17 and 22 ones.